Alright, so let's take a look at these next two here. We're going to solve using the quadratic formula. So start by labeling your a, b, and c's. So a equals 7, b equals -2, and c equals -16. This is just because this is in standard form. So a is 7, b is -2, and c is -16. Then we're going to find the value of the discriminant. So b squared minus 4ac. So it's going to be -2 squared minus 4 times a times c. So you do that on your calculator, you're going to get 4 plus 28 times 16. $448 plus 4 gives us 452. And so now when we go to the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a, by already evaluating the b squared minus 4ac, it just saves me a little bit of steps. So it's going to be negative. My b is -2, so -2 plus or minus the square root of 452 all over 2 times a, which is 7. So this gives us 2 plus or minus the square root of 452 all over 14. Now just do this in your calculator. 2 plus the square root of 452 equals, divided by 14, and then 2 minus the square root of 452 equals, divided by 14. So you get -1.66 and -1.38. Okay, so we're going to do the same thing over here. So we have our ax squared plus bx plus c. So my a value is 2, my b value is 8, and my c value is -6. Start by finding our discriminant, b squared minus 4ac. So it's going to be 8 squared minus 4 times a times c. So 64 plus 48, which equals 112. So now when we go to our quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So my b is 8, so it's -8 plus or minus the square root of 112 over 2 times a is 2, so 2 times 2 is 4. And now this is what I'm going to plug into the calculator. Alright, so you get 0.65 and -4.65. Alright, so to convert this into vertex form, what we're going to do is we're going to complete the square on this. And so to complete the square, we're going to get rid of the 10. So I'm just going to move the 10 to the other side. So I'm going to -10. And so on the left side, it's just y minus 10 equals x squared plus 6x. And so to complete the square, draw our little square. And we look at this. What's half of 6? Squared. And so I'm going to put a 9 here and a 9 here. So on the left side, the -10 plus 9 gives us y minus 1. Here on the right, we want to factor this. So this perfect trinomial factors to x plus half of that 6, which is 3. So this is equivalent to this. And now I just want to move the one to the right side to put it in vertex form, because in vertex form the y is going to be by itself. So I get y equals x plus 3 quantity squared plus 1. So this is equivalent to this. So just to make sure I got that right, I graphed this in Desmos, the x squared plus 6x plus 10. And now I'm going to graph the x plus 3 quantity squared plus 1. And if I'm right, it should be exactly on the other graph. So that means that these two things are equivalent. Okay, so now to go from vertex form to standard form. Remember, this square really just means that there's two of them. And so now you can just FOIL it out. X squared, so this would give us minus 5x minus 5x, so that gives us minus 10x. And then the negative 5 and negative 5 gives us positive 25. And then don't forget about that plus 2. And so this becomes y equals x squared minus 10x plus 27. So again, you could check that into Desmos. And then finally over here, we're going to go to vertex form. So to go to vertex form, I'm going to have to go to standard form first. So I'm going to FOIL that out. And so I get x squared plus 2x minus 8. And I'll go down here to give a little bit more room. So now I'm going to complete the square on this. So when I complete the square, I'm going to move that 8 over just to get it out of the way. So y plus 8 plus the square equals x squared plus 2x plus the square. So we take half of 2, square it, so we're going to add 1 to both sides. So now we factor the right side. So this factors to x plus 1 quantity squared. Here the 8 and 1 is going to give us 9, so y plus 9. So now to put it in vertex form, we subtract the 9 from both sides. And we finish with y equals x plus 1 quantity squared minus 9.